guys, okay, we're going to get started with Chapter 5, Relationships Within Triangles. In 48, we're going to describe the median. Well, the median is a segment that goes through the vertex of a triangle to the opposite sides midpoint. The three medians meet at a place called the centroid. Alright, so that's a median. The altitude, again, goes through the vertex of a triangle, the vertexes. And it's perpendicular to the opposite side. It doesn't hit the midpoint or anything special. It's simply perpendicular to the opposite side. The three altitudes meet at a point called the orthocenter. An angle bisector, a segment that cuts through an angle, dividing it into two congruent pieces. Congruent pieces, and it meets at a point called the incenter. Called the incenter. Very exciting vocabulary here. Perpendicular bisector can go through an angle or side, go through a vertex or side of a triangle. And goes through the opposite sides midpoint. The opposite sides midpoint. Also creating a 90-degree angle. They meet at a point called the circumcenter. Alright, so this is equidistant from the angles of a triangle. Or from the vertices. The incenter is equidistant. Remember, equal distant from the sides of a triangle the centroid is the point of balance in a triangle. Point of balance meaning if you wanted to balance a triangle on your finger, you would find the centroid and it would be able to balance there. And the orthocenter is simply where the three altitudes intersect. And there you have it. That is those definitions. Make sure that you learn the special properties. Oh, centroid, I forgot. Remember, it's broken into thirds. Broken into thirds. The longer piece is 2/3, and the shorter piece is 1/3. Okay, so let's move on to some problems now. It says, number 49, the triangle has the vertices Okay, so triangle XYZ has these vertices. X is -2 and 8. Y is 6 and -2. And Z is 4 and -10. I'm going to plot these so that I can get a better visual. I'm going to go up to 8 on all sides, or 10 on all sides of my graph. 3, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hopefully I didn't miscount. 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, that one I'll have to end at 9. I'll go over -2 and up 8. This will be point X. And then I'm going to go over for Y over 6. 3, 4, 5, 6, and down -2. And that will be Y, and Z over 4, and 1, 2, 3, 4, down -10, right about here. And that will be Z. I'll connect my points, and that way I get a visual. It says it wants me to find the slope of the perpendicular bisector of XZ, which is right here, this segment, XZ. So what I want to do is I want to take the points X and Z and find their slope. Find slope of XZ. Remember, this is X1, Y1, X2, Y2. And I'm going to do -10 minus 8 over 4 minus -2. Remember, two negatives side by side here become a positive. I'll get -18 over 6, which simplifies down to -3. So my slope of XZ equals -3. Remember, I need the perpendicular bisector, the slope of it. So perpendicular is opposite reciprocal. Well, the opposite of -3 is +3, and then the reciprocal is 1 over 3. I just flip it as a fraction. So my slope, my perpendicular bisector of slope XZ is going to be a +1/3. Okay, so that's number 49. Moving on to 50, it says x, yz has the vertices -2, 8, 6, -2, 4, -10. Find the coordinates of ZA if ZA is the median of XYZ. Okay, so what I would do is I would go ahead and I could draw a triangle so that hopefully I can understand where ZA might be. So XYZ. Now the ZA. So across from Z is XY. So what I want to do is I want to find the median, which is this point right there, or where the median hits the opposite side A. So what I need to do is I need to use the midpoint formula because the median hits the midpoint, and I need to find the midpoint between X and Y. So midpoint formula. Remember, that's x1 plus x2 over 2 and y1 plus y2 over 2. So, and it's of xy, right? So I'm going to look at x and y. I am going to take -2 and add it to 6. Put it over 2. That will be my x values. And 8 and add it to -2 and put it over 2. That becomes 4 over 2 and 6 over 2. Well, we simplify both of these points and we end up with A equals 2, 3. 2, 3 is our A value. Okay, so the next thing that we want to do is we want to move on to question number 51. It says list the angles of triangle AMK in order from least to greatest. Make sure you pay attention to that. So let's go ahead and draw AMK. All right, AMK. Well, it gives us AM. It says that it's x plus 12, so I'm going to write that down. And it gives us MK, which it says is 2x minus 7, and AK, which is 3x minus 3. All right, then it gives me the perimeter. Remember, perimeter is all the sides added together. So this side plus this side plus this side. And it equals 32. Since I don't have exact numbers, I'm going to take the expressions they gave me, x plus 12. That'll be one set, and add it to 2x minus 7. And add that to 3x minus 3. And set it all equal to the perimeter, which is 32. So I'm going to combine my like terms, my x's and my constants, the numbers without a variable in front of them. I'm going to get 9x. When I combine these, make sure that you keep the signs in front of them. So that's a -7 and a -3. And I'm going to end up with 9x. 6x plus 2 equals 32. I made a mistake combining my like terms. Sorry about that. Subtract 2, I have 6x equals 30, and x equals 5. All right, so that's x. But it wants me to order from least to greatest. So I'm going to take that x and plug it in. So that's going to be 5 plus 12, which equals 17. That will be one side. I'll take 5 times 3 and subtract 3, which will give me 12. That will be this side. And once I plug that in, 2 times 5 minus 7 will give me 3. And I can see, based on my sides, which angle is the largest and which angle is the smallest. Remember, across from the smallest side is the smallest angle. So that means angle A, because it's across from the smallest side, is my smallest angle. Angle M is my middle angle.
May I have your attention?
Angle, because it's across from my largest side. And that is ordering angles. In the next video, we'll pick up at 52.